Okay, let's look at curve sketching. All right, so let's dive right into an example. All right, let's try to sketch the graph of f of x is equal to x over x squared minus 4. All right, so first we look at the original function, see if we can get a bunch of information there. All right, so looking at the original function, we can find the domain. Right, so since it's a rational function, we have to worry about the denominator being equal to 0. Right, so you see that we don't want x squared minus 4, which can be factored out as x plus 2 times quantity x minus 2. Right, so we don't want this guy to be 0. Right, so we know that x cannot be, right, we don't want x to be negative 2 or positive 2. Right, so domain is going to be all real numbers except positive 2 or negative 2. So it's going to be, if you write it in interval notation, it's going to be negative infinity to negative 2, skip negative 2, go from negative 2 to positive 2, and skip 2, then go all the way to positive infinity. Right, so that would be the domain. All right, x-intercept and y-intercept. In order to find x-intercept, we set this guy, original function, equal to 0. Right, but in order to make the fraction equal to 0, we have to make sure that the numerator equal to 0, so which means that the x must be 0. So x-intercept is 0. Right, y-intercept is easy, you just plug in x equal to 0, but f of 0 is also equal to 0. Right, so y-intercept is also 0, which just means that the graph is going to go through the origin. All right, then let's find the vertical asymptotes. All right, vertical asymptote when the denominator equal to 0, not the numerator. So we already know that when x equals positive 2 and negative 2. So vertical asymptotes are x equals negative 2 and also x equals positive 2. Right, horizontal asymptotes. Right, so in order to find a horizontal asymptote, in this case we can use the trick. If a bottom guy has a higher power, higher degree, in this case 2, and the top is degree 1, so the horizontal asymptote is y equals 0. Right, so we got those pieces of information. All right, so let's look at the derivatives to see if we can get a bunch of information from there. All right, let's take the first derivative. All right, so f prime of x is equal to, all right, so we have to use a quotient rule. All right, square the denominator, so it's going to be x squared minus 4 squared. All right, derivative of the top is 1 times the bottom, which is x squared minus 4 minus top is x times derivative of the bottom, which is 2x. Right, so if you simplify that, all right, so you see that you have here you have 2x squared minus 2x squared, you have x squared there, so it's going to be negative, I'm going to put the negative sign in front, x squared. Right, so that will take care of this guy right here and this guy right there. Right, and also we have negative 4, so negative sign is already factored out, so it's going to be a plus 4. Right, then you have quantity x squared minus 4 squared. Right, and you can see that since there's a square here, denominator is positive, and you have an x squared plus 4, so that's positive, with the negative sign. So this first derivative is always negative, which means that we know that this is always, original function is, or f is always decreasing, right? Because the first derivative seems to be always negative, right? So we have that. All right, then we can look at the concavity by examining the second derivative. So we have to take another derivative. So f double prime of x is equal to, all right, so another quotient rule here, all right? So there's a negative sign here, so I put the negative sign out here, all right? So square the bottom, so you have quantity x squared minus 4. It's already squared, so it's going to be to the 4th power, right? And the derivative of the top is 2x, so 2x times the bottom, which is x squared minus 4 quantity squared, minus top guy is quantity x squared plus 4 times derivative of the bottom. So it's a general power rule, so 2 in front, quantity x squared minus 4, and then to the first power multiplied by derivative inside, which is 2x, right? So you have to use a chain rule there. All right, then we need to clean up a little bit, right? So let's find common factors, right? So we have 2x here, and there's 2x there, so we can pull that out, right? So let's say there's a negative sign in front, and then you have 2x, so I factor 2x out. And also we have x squared minus 4, so that's this guy, and there are actually 2 of them, so I'm going to just circle the power so that I know that there's another one here. So we have x squared minus 4, right? So we got that, and anything else, right? I think it looks like that's it. So let's collect all the leftover term. So we have, right, so from the first term we have x squared minus 4, all right? So x squared minus 4, right? From the second term you would have, let's see, negative 2 times x squared plus 4, all right? So that would be negative 2x squared, right? And minus 2 times 4, minus 8, right? Then over x squared minus 4 to the 4th power, right? Let's clean that up. Let's say you have x squared minus 4 here, right? Then we can cancel one of them, so that's going to be a to the 3rd power, all right? And this guy right here, this guy can be simplified as negative x squared, right, by combining x squared and a minus 2x squared, and a negative 4 and a negative 8 will make it negative 12, right? So we can simplify it as, right, so there's a negative sign right here, so there's a negative sign here. I'm gonna incorporate this guy to those 2 negative signs here and there, right, to turn them into positive sign. So you're gonna have 2x, right? So that's gone, so it's going to be positive x squared plus 12, right, all over, right? You have a quantity x squared minus 4 cubed, right? so we found the second derivative. Alright, so let's do a number line on this guy. So I'm gonna probably draw a number line up here. Alright, so we need the tick marks for, so if you set this guy equal to 0, right, only thing you can make it 0 is, this is always positive, so we have to make x equals 0, right? This is the only way we can make it 0, so x equals 0, right? So I'm gonna put a 0 here. Right. Also remember that the domain, we cannot have +2 or -2, so we're gonna mark those. Right, so it's going to be -2 here and a +2 there. Right, so let's look at the sign of the second derivative. So f double prime. Right, so we can try any number less than -2. So we can try -3. Right, so if you plug in -3, let's see, so this expression is always positive, so we don't have to worry about that. Right, so if you plug in -3, so 2x would be negative, right? And if you put -3, -3 squared minus 4 is positive cubic, so that's going to be positive, right? So negative, positive divided by positive is negative, so you have a negative sign here, right? And between -1, so that's negative. Right, between -2 and 0, so we can try -1, right? Then we can do a sign analysis. So this is still negative, this is still positive. This one, if you have -1 squared minus 4 is -3, so it's actually negative. So this guy is now negative, right? Which makes it negative, positive divided by negative is positive, so it's going to be positive here. All right, and the same way we can try 1 for between 0 and 2. So second derivative at 1, right? So now this is positive, this is positive, this is going to be negative, so it's going to be negative here. All right. Right, last interval, we can try +3. Right, +3, that's positive, that's always positive. +3 squared minus 4 is positive, right? So you have a positive sign here, right? Right, which tells you that you have f is going to be concave down here, concave up here, oops, concave up here, right? This is concave down here and a concave up there. All right, so you can see that there's a concavity change every time you hit those tick marks. All right, let's sketch the picture, kind of putting all together. All right. Alright, so we know that the domain exclude the +1 and -2. So we're going to put the tick marks for -2. And here, +2. Right? There's a vertical asymptote there. So we're going to draw a vertical asymptote. Right? Right? This is our vertical asymptote. Right, and also there's a x equals 2 is another vertical asymptote, so we can put that in there. Right, so we have another vertical asymptote there. Right, and then horizontal asymptote is y-axis, I mean x-axis. So you have it's kind of hard to see, but the x-axis is the horizontal asymptote, right? So we got that, and the x-intercept is 0, y-intercept is 0, so which just means that the graph is going to go through this point right here. Right, so let's try to sketch the graph. Right, so first derivative tells you that this graph is always decreasing. Right, then look at the first interval here from infinity to -2. So you have to have a concave down shape, you have a horizontal asymptote and a vertical asymptote there. So you can see that it's probably going to look like this. Right? Right, after that you have concave up shape. So between here and there, concave up shape. So you have to hit this point and a concave up shape and decreasing. And so it's going to look like this. Right? And after that, it's going to be a concave down shape, and you have a vertical asymptote there. So a concave down shape and a decreasing. So it's going to look like this. Alright, after that it has to be decreasing and a concave up shape. So, and the vertical asymptote there. So you're going to have a graph which looks like this. Alright, so this is the graph of y equals x over x squared minus 4. Alright, so let's use a computer to sketch the graph to see we get a picture pretty close to the actual picture. Alright, let's do that. Okay, I'm using a free software called GeoGebra, and I'm gonna sketch the graph. Right, so here y equals we have x over x squared minus 4. Right, then hit enter. Right, so you can see that it sketches a graph, and so this is what it looks like. Right, so if you go back to here, right, you see that it basically have the same shape. Right, and the vertical asymptote, if you want to see a vertical asymptote is at x equals -2, which is there, and x equals 2, which is there. Alright, so looks like we did a pretty good job, and you know, this is a graph, but this is what we came up with. Alright, that's it. I hope that this was clear.